right. Welcome everyone to for me it's the last session for Devoxx, but actually started here, the first one on Tuesday. It's great to end it in the same room. Welcome to this talk, Rest Beyond the Obvious. I'm really delighted to see so many people attending because I thought it could have been rather, well, is it a topic that really attracts people, right? So, my name is Oliver Gierke. Oh, sorry about that. Where are we going? Ah, sheesh. Where is that? There we go. It was Oliver Gierke. Sorry for that. It's Oliver Drotbaum now. I'm the living proof that calling get methods sometimes has side effects, like try get married, and then you actually have to change all your online identities. That's kind of a bit of a weird thing right now, but still the same guy, developing Spring Data mostly for a company called Pivotal. But today I'm here to talk about REST, and REST, as the title suggests, beyond the obvious. What do I mean with that? There's a couple of things that are pretty fundamental about REST, like things like resources, URIs, representations, and I'm sort of assuming that you're at least vaguely familiar with those. So I'm not going to talk about like nice URI design or any of these things, but rather try to have a look at the idea, and especially as you can't escape the REST is broken, or we don't need REST anymore, or GraphQL is the new REST kind of thing these days. And it's kind of like, I thought it was time to actually have a look at it from an architectural point of view. What's the way it actually makes things work? And also the fundamental idea that if we like move to an age of systems communicating with other systems, that's sort of similar to actually what the internet works like, right? So it's kind of like you have different servers and they're just getting connected via links and what have you. So is there maybe something to learn if we want to build a system that's fundamentally structured the same way, with systems coming and going and what have you? So the point of view I'd like to take on REST is it's like, okay, what's the starting point and what are the effects? So if you read up on the dissertation that Roy wrote a couple of years ago, or a lot of people think that it's actually a dissertation about REST, and it's actually not. It's kind of a piece of work to analyze different architectural styles and the constraints that are making up these architectural slides. So basically, from the options to design a system, we start to reduce them, basically. We put some constraints on ourselves, and the effect is, or there is some effect in doing that. So if we avoid keeping state around with my client in a client-server system, that actually enables us to talk to any like replica node of the very same system, which enables scalability, right? So there's this kind of constraint that we have to follow to get this actual effect, and that's actually the way I'd like to look at this, right? So we have these constraints as enablers. That's something that's might not be as intuitive in the first place, because if you think, oh, I'm not allowed to do certain things, how can I be creative in that space, right? I'm a drummer myself, and there's this debate between, if you ask around like amongst your friends that are musicians, what kind of drummers do you like? And then you often have these kind of guys, okay, we like Portnoy and whatnot, so drummers that play really big drum kits, like with gazillions of toms and whatnot. And there are drummers that, or even sometimes it's the same drummers, but you can also play a very small kit, which is the bass drum and a snare and whatnot. And actually that playing smaller kits sometimes fosters more creativity, because you have to think about, okay, what can I do here to be actually creative? Right, so what is there's one constraint that I'd like to focus on, even in the set of all the constraints that Roy discusses in the thesis, which is evolvability. And why do I think this is something that I want to do? The thing is that when we're building a system that's composed of other systems, then we do that because we want to be able to evolve these systems individually, right? So you're doing, I mean, there might be technical reasons why you're doing microservices, scalability requirements, but most often it is that the business wants to ship features faster, right? And the assumption is that if we isolate a certain set of features, a bounded context in domain-driven design speak, into a singular system. We can have a team around it, and we can let that team deploy new features. And what puzzles me about that is, or what puzzles me in consequence, is that everyone seems to be very, very eager to find out the fastest way to build a new microservice, where that's actually not what we wanted to focus on, right? We wanted to be able to change the system subsequently. So building the thing is one thing, but then being able to change it and not breaking all the other systems is kind of the important thing here. And to discuss that, I'd like to basically take 3 steps. Let's start with some context. So where does the way that we build what we call REST APIs actually come from? What's the history behind it? Because I really think that the way that these APIs look like today is fundamentally shaped by the way we actually got here. And what we have to look at in the first place is the relationship between the clients and the servers. So we have a system that's like in an advanced context composed of multiple systems, but fundamentally, let's assume first we have one client and one server system. And if you're like old like me and remember the old days, we actually had these times when we were shipping applications that were producing HTML on a server, right? JSP, anyone? Which meant that all the business logic was contained on the server, right? So we have business logic that creates a representation that's understood, fundamentally understood, well understood by the client, the browser in this case, and the browser's only task was to display that, to render that, and then provide, let's say, human approachable affordances, like things that we could interact with, links and buttons and forms, and then basically take us through the application. Back in those days, the internet was pretty slow. I mean, if you're coming from Germany, it's still slow there. But that sort of led to the annoyance that if you have to have a full request and a full page reload per request, it's kind of, annoying. It's slow, it feels sluggish. So that's why we thought, okay, let's have a bit of JavaScript in the browser, right? Deploy some, Roy calls this code on demand, so the server is actually able to send some code to the client to be executed, so that we can do certain things in the browser already. That was to just maybe avoid full page reload. Let's say we do some form verification, validation of credit card numbers or what have you, right? And if that process is often like, if I talk to people say, okay, we move some business logic to the client, and actually that's not what's happening, because what you actually do is you replicate that business logic into the client, because there's no way you disable that credit card verification just because you have some JavaScript in some browser preventing some form submission, right? I mean, that would be pretty stupid, right? Otherwise, you could just like give basically open up the database to the client and then let some user interact with it, deploy a PHP MyAdmin or what have you. So when does this model actually work? Well, when you have basically the same, if you have the same team actually taking care of the development of that particular client, that kind of web application, that web layer basically. So the question is, okay, that actually works if you are in charge of the client, if you control the development of that piece of code that's running in the browser, those assumptions, because then you can actually go ahead and in case there's a change in business functionality coming, you'd probably change it on the server and change it in the JavaScript and just redeploy it and you'll be done with it. Nowadays, the things have changed slightly. I get into more and more customer discussions where there's the discussion of a so-called front-end app and the back-end app. And the front-end app is something like, or the front-end itself, it's a separate application, a separate team working on it. Usually something Angular, what have you, purely JavaScript, right? And the separation into teams usually leads to the fact that they want to release in a separate pace, right? So the question is, do you actually control the client's releases? If that's not the case anymore, if there's a separate team responsible for actually performing the release, that update of business functionality can actually become quite harder because you now have to synchronize, right? Does the client team already, or do the check, the credit card number verification check already, the change in that, and then you have to sort of deploy both at the same time. And that thing gets even worse if you add mobile to the mix, because then not only you're talking about like a web client, but it might be yet another team, right? I mean, you might be lucky that there's the same team working on the website and maybe the iOS, the Android client, what have you. But let's assume it's a separate team again. Then you now all of a sudden create a third party that actually has to keep up with your changes you want to make on the server side. And things get even worse with that, because even if you actually decide to deploy everything together, you're not really in charge anymore of the deployment of your new releases, right? If you decide to release together, that's what I was trying to say. You're not in charge of the deployment, because if a user actually installs your latest update, it's not really guaranteed, right? There's a couple of mechanisms in iOS and I guess Android as well to increase or create incentives for users to upgrade frequently, but it's getting fundamentally more complicated. And what I'm trying to get to is that the structure or the way that this API was shaped was that we sort of transfer we have the business logic hard-coded in either side of the system. And a change in that functionality is actually the effort for that is multiplied by the number of like separate teams that we actually create around that service. And especially in API design, this can lead to very interesting effects, because as I said before, if you have teams that are concentrated on just building things quickly, like there's a gazillion of tools out there that let you, or that are at least advertised as you being able to just by a flip switch, turn on, create some API, and some annotation here, some annotation there, and then you get some fancy UI to click on. I guess you know which one I'm referring to. But to basically ease that initial creation, right? But at the same time, with a change in the functionality that you expose via that API, you create a lot of effort in the other teams. So if you optimize for just like local initial creation, you might just end up with a bad situation overall if you actually consider all the clients that actually need to update. And again, that brings me back to that evolvability thing. It's fundamentally, in a system of systems, it's fundamentally important to actually have a look on the overall effect of the way we design APIs, right? So we want to design for the flexibility in the API to make changes. And the less likely it is that we break a client with a change in our API, the better, right? Because that reduces the effort, which is then multiplied into the number of clients. Abstraction. I borrowed a slide from a colleague of mine, or not working for Pivotal, but fellow Rastafarian, actually, Stefan Tilkov. He has a talk about integrating the way, or the different ways that you could actually integrate systems, and that sort of translates nicely into what I'm trying to get at. So the first level that you could put or build your API on, the abstraction level, is basically just taking the data that your service has and expose that via HTTP. So you could go ahead and naively just take every table, turn that into JSON, and then have a resource, an HTTP resource, that actually exposes the data of that table, right? So you can have like all customers under /customers and a single customer under customer/ID. If you think about that, let's take a step back from the web APIs. If you think about that in terms of like a Java application, let's say you have your data access layer implemented with JPA, so you have an entity manager and you have some code that's actually implementing that. In that scenario, where does the business logic live? Anyone? In the client code, right? In the code interacting with that level. And that's actually the scenario that we wanted to avoid, right? We wanted to avoid that all the verifications, all the validations, all the business logic actually leaks into the clients, because then it's going to be multiplied amongst different client implementation and has to be kept in sync. And there's something you can actually add on top of that which is, and that's what we actually do with the Spring Data REST module. I don't want to spend too much time on that, but the domain model that you code for your application usually has quite a bit more information in it than just the raw database table. So there's aggregate structures in there, especially if you don't have to use Spring Data repositories, but repositories in general. You form aggregates, you form clusters of entities, and that already allows you to expose a slightly more sophisticated structure, because the lower level actually has the disadvantage of you have to answer the question where to draw the boundaries for the representation. Let's say you have the order, and an order has line items, and the line item refers to a product, and the product has seller information, right? If you hand that order object to Jackson, where is Jackson supposed to draw the line here? And that's actually information that you usually encode in your domain logic, in your domain objects, and that's something that we make usable in the Spring project with Spring Data REST. However, that's not actually it, right? So there's more to it actually, because we still are not able on that abstraction level to sort of encode process flow. So things like, okay, I can order something, and what point in time what point in time in the life cycle of an order am I allowed to cancel it actually? So business rules that are more advanced than just like a verification of a credit card number. So ideally, an API exposes is exposed on that level. And the question that I'd like to answer in the remainder of the talk is how we actually can get to that level with your API implementation, and what helps you with that, and what kind of means actually REST actually exposes to achieve that. Stefan concludes the slide with suggests to integrate applications on the presentation level. That's not that relevant for discussion here, but I just added it for the sake of completeness. There's one observation that I think is quite important, because I usually get into discussions and ask people why they actually build their HTTP-based API the way they do that, and they tell me, okay, yeah, because if I have this collection resource, item resource pattern, and it's very generic, and every client actually understands it, but as you hopefully have seen before in that section when we discussed the client relationship, there's some irony in there, or something that's not obvious, because the more generic the API actually becomes, the more the actual stuff, the actual meat of your business process has to be implemented in the clients, right? Because the abstraction level basically goes down. All right. Coming back to this slide, so what we actually see, or the way the abstraction level are implemented in APIs is usually that. So we have a lot of logic on the server. We have a bit of the data lives on the server. The constraints for the data live on the server. There's some domain logic implemented in both the client and the server, but everything else, process flow and whatnot, lives in the client. In other words, is hard coded into the client. Let me get a bit ahead of myself. The fundamental question, when is a user allowed to cancel an order, is implemented in the clients. And yeah, that's kind of problematic for the reasons discussed earlier. Right. So the question is there a way to actually change that graphic here, to change that model, to keep more of the business logic on the server, right? I'm not arguing we should remove everything from the client. We should have just dump clients. It's just that, okay, the stuff that's going to change a lot, and yeah, that's probably what it does in your projects. Is there a way to actually keep that more on the server? We want to prevent that leakage of business logic into the clients. And to find out about that, I briefly want to discuss the topic of coupling. So where does coupling actually come from? What couples two things together? Actually, it's contracts, right? So if at least two parties agree on something, that's kind of a contract, right? And I want to start with an example that's not even touching REST APIs yet, but just a plain Java-based example. Assume we have some kind of service that returns a value, and that value has a property and enumeration salutation of Mr. and Mrs. in this case, right? So in a Java context, the calling code and the called code is in the same compilation unit, that's a pretty strong contract here, strong coupling, and that's actually what we want. Why do we want that? Because we can then use tools to help us change that code, right? We can use the refactoring tools in our IDEs to change the method name, to change property names, what have you, right? And I'd like to propose a that's this user account and the values in here. So I'd like to propose a change to the API that's actually even considered to be non-breaking, right? So we want to add a value. We want to add something to the API. So what if we just want to add the professor value to the salutation? So if we do that and we still control the compilation space of the client, the calling code and the called code, there's absolutely no problem because our client code is immediately aware of the new value. And if I return a user account object with that salutation, I can actually use it from that code. It already gets more complicated if it's not the same compilation space, right? If the calling code lives in a separate jar, because then the change on the providing side of things actually would cause if we return an object with that new value, the client code might not actually or will not be aware of that new value. Yay to the default statement in the switch case clause, right? Because then that prof value would actually trigger the execution to run in there. What do we do to actually counter that? Let's say in the plain Java space, we use versions for that, right? So we have artifacts that are versioned, and then we depend on a certain version of a providing API, and then we use that. And if we upgrade, we sort of check for compilation errors, fix them, what have you. But it already complicates the picture. So yeah, we add the new value. So what if we actually go ahead and take this example and turn that or move that up to the web API level? So if you let your $famous API definition tool just analyze that code, that's what they usually do, it will happily analyze, oh, you've got an enum in here, and that enum has certain values. And this is JSON schema, actually, just an excerpt from that. So it has these Mr. and Mrs. values in there, right? And if you expose these schemas, what is the client usually going to do? Oh, we don't want to interact with the schema, right? We want to have some code to code against, actually. So we generate some code from that. So we create some statically compiled code, and then we go ahead on the server and change the value from this to that, and then send that back to the client, and then the client breaks because the statically generated code from that schema definition is just not expecting the value, right? So it can't actually bind that prof value because in its statically typed generated code, it's not available. So the interesting bit is you can argue, okay, are you saying we should avoid code generation? Yeah, why not? I mean, there's this famous Kevin Henney quote, code generation so that you can do the wrong thing faster. That's sort of in play here. But there's a more fundamental issue, because why is that client developer actually getting the idea of generating code? Because there's like stuff statically documented, and what other opportunity or possibility has that $famous API definition tool than actually inspecting what you have statically defined? What it doesn't know about is that certain parts of those structures might actually be intended for extension later on. And that's why it's very critical that you really review, if you're using these kinds of tools, that you really review what you actually expose, because you might expose internals or might expose things as assumed static, which are fundamentally not, right? And even more fundamentally, what I'm trying to get to is, and that's something that puzzles me in these discussions usually, is that this kind of API derivation, this web API derivation from analyzing code, is pretty much coming from the assumption that we could do the same things that we do in Java, like strongly specify all these constraints, and sort of sort of end up with something different, right? If we strongly specify these interfaces and these contracts, we come to strong coupling. And I'd argue in case of Java code, this is wanted because we can actually use that strong coupling to enable refactoring, right? To enable tools to actually analyze that. However, it puzzles me that if you move that to the web space, you actually think you could do the same things in defining the API, but end up with some magically loosely coupled REST APIs. That's not going to work, right? It's not. We can't do the same thing and expect a different kind of output. The fundamental mechanism at play here is called kinases. It ran across my desk by when I don't remember the reason why I actually watched a talk, The Grand Unified Theory, on YouTube. I mean, why would you do that? It's probably some Twitter feed, Jim Weirick. It's actually, it's from a Ruby conference, but he outlines the concept here. The concept itself is from a book, not actually written by him, but pretty interesting. And just to boil things down to the most important thing here is, kinases describes the form of coupling, or the degree of coupling. That's it. And it basically means, okay, if we have two things that are born together, what do we actually have to do to actually adapt what do we have to do? What do we have to do? Sorry, to keep them in sync, right? If we change one side, what do we have to do to the other side? And the fundamental rule that Amelia Page Jones comes out with is that the stronger forms of kinases are perfectly acceptable if the two parties are closely related. In other words, if they're part of the same compilation unit. If they're more distantly related, then we have to fundamentally move to lesser forms of kinases. I'll give you an example of what that can actually be. But it's the point is that the strong definitions of API descriptions can be a problem if you really want to get to low coupling. So just to give you an example, if you imagine, like in Java, you have method parameters. The method parameter order is important. That's basically, what is it? Kinases of position, right? So if we want to call a method, the calling code has to hand in the parameters in the right order. If you have a language that has the notion of named parameters, the order doesn't matter because you actually hand in the names as well. So you define first name. Take this as the first name, like SQL, for example, right? If you provide an insert statement, there's no way you have to use the same order than when you defined the table structure. You just define insert into values and then define the column, define the value. And that actually allows the provider to change that. So that's basically the point. So let's say we have developers being trapped by this strong coupling because they just like $famous API definition tool. And then they find, okay, we need to change something, and that breaks the clients. What do we do? And that ultimately leads to that effect here. And the interesting aspect, or the reason, I mean, there's this famous article on InfoQ where Roy gets asked, how do you actually version? And he said, okay, you just don't do it. That's a bit of a provocative statement. I can see that, but the fundamental idea is that a version is nothing different than just a new service that you deploy, right? In terms of maintenance, in terms of, oh, the client needs to be updated to talk to this new thing, and that it's 90% the same thing doesn't actually matter that much. Again, I think the primary focus of when building APIs should not be how do I version this thing, but how do I build the system in a way that I can change it as much as possible without breaking clients. Again, I think I said that before. A new version is a new service thing is actually backed by a bit of a study by a guy called Jacques Dubré. There's a blog post where there's a pretty scientific research on, or at least it's the most scientific research I could find on that topic, where they basically compared the cost of development and the cost of maintenance for different API compatibility strategies. So in this graph, version, like the green bar in this graph means a new version is completely backwards compatible to the old version. And there's like two different strategies of integrating non-compatible versions, and I recommend to read up on that. That, of course, includes not only the effort to maintain the server, but also to eventually migrate all the clients. Again, that's most of the issue here, to move all of the clients to the new API. Right. All right. So what am I proposing instead? I'm fundamentally proposing to have the courage to explore areas of REST that you might not have explored yet. And it fundamentally brings me back to that, okay, we have these architectural constraints and the effects. Because the interesting thing is that the dissertation is pretty clear. The aspect of hypermedia is part of the uniform interface constraint in the dissertation, and that constraint is described to have a huge influence on the evolvability of systems. And that's why I think it's puzzling if people say, okay, we don't need hypermedia, and then the next question is, how do I version my service? Right? It's basically you're saying, okay, I don't want to follow this constraint, but I'm disappointed that I don't get the effect that REST promised in the first place. So the fundamental idea, I tried to take this in two steps. The fundamental first idea is that we're not only returning data, but also navigation information, which means there's some form of links representable in the representation. If you imagine HTML, that's pretty straightforward. There's an anchor tag, and then you have some description. And like a mere mortal can actually, or will get the stuff presented, and then will click on it if it sees fit. That's pretty static. So it's already something. So if you remember that domain logic level in the abstraction slide I had, you can actually, by analyzing your domain objects and your aggregates, you can actually, instead of including the customer data in the order representation, you can just point to the customer. Right, but it will always be there. It's like, let's say there's a non-nullable constraint on that relationship. You have means to point to other things. That's already kind of helpful and kind of neat in a microservices environment, because that actually allows you to restructure your servers without the client actually having to know about that. Right? So let's say we have our orders and our customer living in the same system, then the client would just get the link, and the link by accident would point to the very same system, the very same server of the same port in the same machine. If you decide to split up the systems, have the customer management on a completely new system, you just start returning links that point to another machine. You don't actually have to start splitting up systems in the first place. It might just be pointing to another instance of the same monolithic server. So there's quite a bit of flexibility here, and that's pretty helpful. What actually helps in the evolvability aspect is something that's called Hypermedia as the engine of application state. It has a pretty unpronounceable acronym for that. But the idea is that we're not statically serving these links, but conditionally. And actually, that's what there's this state thing in REST, representational state transfer. So depending on the state of the resource, we return links that indicate whether a client is allowed or is supposed to do something or not. To give you an example for that, I took an example from a book called REST in Practice by Jim Weber, Ian Robinson, and Savas Parastadidis. With O'Reilly, I'm not sure they have that down there at the books. At the book stage. It's an implementation of or trying to implement a RESTful API for a coffee shop ordering experience, as you probably can suggest from the name. So what we do here is we take the order through a set of states. There's no coincidence that this pretty much looks like a state machine, because that's sort of how the web works in the first place, or REST works in the first place. It says representational state transfer. So we use representations to transfer resources from one state into another. The idea here is we have an order that can be in different states. We can place the order, we can update the order, and then we have to decide whether we want to cancel it or pay for it. If we pay for it, it's going to be prepared. Then we walk over to that other counter, and then eventually receive our order, and then we just have a look at how weirdly they spelled our name, and then we just go and enjoy our coffee, right? If you just get that requirement and you naively and with the usual tools implement that API, you'd probably end up with something like this, right? That's a straightforward thing to do. You know REST is about resources and about HTTP methods used correctly, and then you just like create something like this, let something like this be created by whatever tool. Fine. What's the issue with that? If you just look at that thing, can anyone at a quick glance find out which HTTP methods to which URI we have to call to actually achieve something meaningful? How do we actually implement an order? That's totally implement an order process. It's totally non-obvious from all of these individual resources. It's basically like throwing out a box of Lego in front of you and hiding the description of what you actually want to build. That's fine if you just want to be creative with something, but actually if you want to build that Star Wars kind of thing, what have you, then it's pretty helpful to actually have a description of how to assemble these things, right? And in particular, the dynamic things are interesting. So the delete request to cancel an order is only allowed in a certain state, and that's pretty hard to express in a very static and resource-centric way, isn't it? So let's say we have this representation. So we want to access the order and want to find out how do we actually know that we want to display the cancel button. Let's say we want to implement an iOS client for that, right? So we skim through the documentation, and then it basically says, there's a status thing, right? It's a payment expected. So how do we actually know that? We consult the documentation, and we ultimately end up implementing code that's inspecting the payload, right? So this is the thing we're looking for. Okay, so we build that, test that, all works, ship that to the App Store. We all install that, and then someone from the business team comes along and says, guess what? Payment expected is weird for, let's say the Germans don't understand English. We want to have like internationalized text. And the development team's reaction is this. Because it actually, you could go ahead and implement a new field, but it's fundamentally, we implemented some assumptions in the client that we now would have to change, and let's make a new version, right? Yeah. So what could have we done better in the first place? Instead of, and that's, again, I'm coming back to, it's fundamentally about what, as a server, you expose to your clients, because with what you expose, you create certain incentives about what they were going to do. And the thing is that the client doesn't have to know about URI structures in the first place. We could just change our documentation model to, dear client, let's agree on something. We create a different kind of contract here. Whenever you have to be able to identify links, you have to be able to find links. There's some RFCs for that. We will, let's say, use HAL as the JSON dialect to actually express links. And you now have to find some HAL library to actually find them. And then we basically tell you that there will be links of certain names. And when these names or these links of these names appear, then you are able to do something. In other words, you can go ahead and now implement your or change your implementation to find out about whether an order is allowed to be cancelled by just looking for that bloody cancel link in the representation. And what have we done here? So, like, first and foremost, we have simplified the decision making quite a lot, right? Before, we sort of had to have a lot of knowledge about this. The business structure or the domain information about what the order was actually comprised of. Now we sort of have a cancel link present, do that. Cancel link not present, don't do that. It's like pretty dumb and straightforward. And what's ultimately at play here is that we're trading two kinds of knowledges basically against each other. One is what I call domain knowledge, like intimate knowledge about, okay, there is a status that is payment expected, which is actually a replication of probably some code on the server side, because there will be, let's say, a check when you call the pay stuff method. There will be a check if the order is not in payment expected state, then reject that thing, or only proceed with the method invocation if that is the case. And on the other hand, we have this, what I call protocol complexity or protocol knowledge, which is the client knowing about things like, oh, this is HAL. I know how to find links in the representation I get back. I know what a URI template is. I know how to implement or expand the URI template if it actually has placeholders. So to make that a bit more graphical, let's have the non-hypermedia based systems like option 1 class systems on the left side of things, and hypermedia based systems on the very right. So in my first example, or in option 1, I had a lot of domain knowledge in the client, right? I knew about not only the structure, I didn't only know about the fact that there's a status field, but I assigned some business semantics to the value of the field. And that's actually where the coupling comes from. The coupling doesn't come from the client knowing about a first name field or the last name field of customer. It comes from the client assigning semantics to the left or to the right side of the key value combination. In the second option, we actually had more protocol knowledge in the client. So the client had to be able to understand all these more technical things like HAL and URI templates and what have you. And I'd argue what's resulting from that is that the coupling in the first example is much higher. Now you can say, well, it's kind of neat. Oh, this way. It's kind of neat that you put it on a slide like this, but I mean, I could just like have changed the colors or whatnot. It's like that's a statement in the first place. I'm suggesting that this is what results from it. But if you think about it, if you implement the client and you have why would you actually rather implement the client based on the more technical things rather than the domain knowledge? Why is that? Well, ask yourself the question, what is going to change more often? Right? Is the way that a URI is actually structured going to change more often? Or very often, is the way that HAL works going to change often? Or is the way that the business actually defines when we're allowed to cancel orders going to change more often? Right? In the example here, and there's actually a fully running Spring Boot based implementation of that available in my personal GitHub. I think I have the coordinates in the back of the slides. But you could go ahead and the business could decide, guess what? If the customer is not satisfied with his or her order, in the very end, we still allow them to cancel that thing. And the only thing you'd have to do is to change the server-side logic to include the link at a later stage in the order lifecycle as well, right? And you don't actually have to redeploy. You don't have to change the client after all. I admit that it's a bit of a contrived example to make my point, but in the best case, that actually even works. Right? So what kind of libraries to round things off do we have in the Spring ecosystem to help you building that kind of stuff? Yeah, first and foremost, there's the library that some fellow in the Spring Data team, Greg Turnquist, maintains most these days. It's a Spring Helios. It contains, it's basically a library which allows you to add links to resources easily, to create links basically by saying, give me the link to point to that controller method in Spring MVC, right? And that rendering that information as in nowadays HAL, we have support for other hypermedia types coming like Siren, Uber, Hellforms is on the roadmap, what have you. Then there's Spring REST docs. It's a test-driven way of actually documenting APIs with the advantage of the creation of the documentation being based on actual interaction with your API. So it's whenever you end up with the server returning a field that you haven't documented, the test will break. Things like that. So you can actually derive the documentation from the test executions. It's based on ASCII doc, and then producing snippets that you can include into your handwritten documentation. There are Spring Cloud Contract that's mostly focused around consumer-driven contracts that don't necessarily fit that model nicely because they're assuming that the client defines what the API does, whereas in the Hypermedia-based approach, it's mostly the server driving it. However, you can still make use of its capability to, again, use the tests to create wire mock stubs so that then the client can actually use those stubs to write integration tests against those Hypermedia flows, that order flow, for example. It's also been used in the Spring REST-Bugs example that I have in my GitHub. To sum things up, prefer higher level APIs over CRUD ones. I know CRUD ones are easier to generate in the first place, however, they bite you in the long run. Hypermedia and late binding, in other words, the client doesn't have to know about the target URIs in the first place. It doesn't have to know about URI structures. It doesn't actually even have to know about the intrinsics or the details of when a certain action is allowed. You can actually indicate that using link presence or not. Generally prefer a protocol knowledge over domain knowledge in your clients. And what I think is key in achieving that is to make sure that documentation is not something that you generate statically and keep statically. It's rather something that should be part of the API in the first place. So, I mean, that's like the REST purists actually get to the self-documenting API notice. But fundamentally, being able to ship the documentation with the API and making it more dynamic basically prevents the clients from getting the idea, oh, let's statically generate some code and actually bake some assumptions into our clients. With that, I have 4 minutes left for, let's say, 1 or 2 questions. Is there any in the audience? Do we have mics around? There's one up there. I guess that's not going to work out. But feel free to just come down after the talk. Thank you very much. Have fun at the rest of the conference.